This Zoom session is brought to you by the Fractal Round Hex Quilt D. Today's session will be about, well, 5/7 special products. This is really quite simple. Squares of sums, squares of differences, and sum times differences. The formula is pretty simple. The square of a sum is a square plus twice a product plus a square. Square of a difference is almost the same. Square minus twice a product plus a square. And a sum times a difference is a difference of squares. I call this first one the 121 rule because the 1, 2, and 1 here. If you take 10 plus 1, that's 11. Squared is 121. So it fits. And I call this one sum times difference equals difference of squares. I call that the 99 rule because if you have A be 10 and B be 1, then this is 11 times 9 equals 100 minus 1, both 99. So, for example, we square 2a plus b. Well, it's square of 2a, that's 4a squared, plus twice 2ab, that's 4ab, plus b squared. 2a minus b, square that. Well, it's the same, except we flip the middle term. So it's 4a squared minus 4ab plus b squared. And here we have a sum times a difference. 2a plus b times 2a minus b is the difference of squares. 2a squared, that's 4a squared, minus a b squared. Now, the book didn't quite go into it, but they did assign these problems. So I'm going to talk about cubes of binomials, so a sum cubed. Well, here's a derivation. You can look it up in the when we're done with the Canvas notes. It's a square times a sum, and the square is a squared plus 2ab plus b squared, and that times a plus b. Well, b times all these are these terms, a times all these are these terms. You add them up, you get a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, but it's 1, 3, 3, 1. You can remember it by noting that 11 cubed is 1,331. A minus b cubed, well, it's pretty much the same, only every odd power of b has a negative sign in front. A cubed minus 3a squared b plus 3ab squared minus b cubed. And the problem set has a couple of these in it. Oh, and by the way, you can go on to fourth powers of sums, fifth powers of sums. It involves something called Pascal's triangle. Maybe I'll mention it later. All right, here we go, some simple ones. The square of 4x plus 5. Okay, square plus twice product plus square. Square of 4x is 16x squared. 2 times 4x times 5 is 40x. 5 squared is 25. 16x squared plus 40x plus 25. We have a square of y plus 0.9. Square plus twice product plus square. First term is y squared. 2 times y times 0.9 is 1.8y. 0.9 squared is 0.81. So this. Y squared plus 1.8y plus 0.81. Here's a sum times a difference. It's a difference of squares, x squared minus 3 squared, or x squared minus 9. Again, a sum times a difference. Difference of squares, square of 2p minus square of 7. That's 4p squared minus 49. Again, it's sum times a difference. Difference of squares, c squared minus square of 3/4 is 9/16. C squared minus 9/16. Now here we have the last two. We have a cube of a sum and a cube of a difference. Now for a cube of a sum, it's cube plus 3 times square times product plus 3 times product times square plus cube. X cubed, 3 times x squared times 4 is 12x squared. 3 times x times 4 squared comes out to 48, 48x. 4 cubed is 64. So x cubed plus 12x squared plus 48x plus 64. We have a cube of a difference, and there it's cube minus 3 times a squared b plus 3ab squared minus b, and this should be a cube, not a square. I'll make a note of that. 574 cube. I shall correct this in the Canvas notes later. So n cubed 3 times 6 is 18 minus 18n squared. 3 times 6 squared is 108 plus 108n. 6 cubed, not squared, is 260. So n cubed minus 18x squared, n squared plus 108n minus 126 is the answer. Okay. All right, let's believe that ends that. Let's make sure. All right. Okay, stop recording.